Let's talk about the two-sample mean t-test. The most important thing is to determine whether to use pooled standard deviation or non-pooled standard deviation. And the easy way to do that is to compare the given standard deviations. Simply put, if the large standard deviation is twice the size or larger than the small standard deviation, then we're going to use the non-pooling formula. Now if we take a look at that mathematically, that's saying S large divided by S small is greater than or equal to 2. So if that happens, use the non-pooled test statistic. And that's the formula on page 3 of your formula sheet. It's in the 4th row of the box on page 3, on the table on page 3. Now, let's take a look at the other way this works out. Well, if we go over to this slide, you'll see the two formulas. This is the non-pooled formula here. If you have that ratio of standard deviations at 2 or larger, this is the formula you're going to use. And you'll notice the denominator is much more compact than the one we're going to look at up here when we do the pooled version. So this is simply the difference in the two means divided by the variance divided by, or pardon me, we're going to divide out the square root of the variance divided by the sample sizes. And that's pretty much all there is to that. It's a nice compact little formula, quick and easy to do. Degrees of freedom for this formula, by the way, you're going to take the smallest of the sample sizes minus 1. Now, if your ratio of standard deviations is less than 2, you get to do this formula here. This one here can be a bit of a calculator workout. Because of the standard deviations, there's 2 square roots in the denominator. Technically, this one here is called our pooled standard deviation, and then we're going to modify it by this guy over here. So unless you're really good with a calculator, I would suggest that you do this 2 square roots separately and then multiply them to get the standard error for the denominator. That would be the easiest way to do that, or perhaps the least error prone. Degrees of freedom, same as the denominator here, is the sum of the 2 sample sizes minus 2. Now we will of course do an example of this, but we'll save that for a separate video. That ends this video.